is committed to contribute optimally to provide education that can be reached by all people virtually. So this is our commitment to spread out the knowledge. That's why we open this to public. So it's not just for us. This is also our contribution to the society and to the nation. Well, without taking further time, ladies and gentlemen, at the end of this meeting, I wish you well throughout this session and for continuing valuable work so that we are able to contribute to the academic and professional field. And as usual, this is a very rare opportunity to have Professor John Kaldi and Toshifumi Matsuoka Sensei in the same forum. So this is very, very precious moment. Please take advantage of it. So ask questions, don't hesitate to ask questions, and then probably to comment or to contribute at least, so that everybody will get value after the sessions. So thank you very much again. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Mr. Budi, for the wonderful opening speech. Now, I would like to welcome Professor Dr. Insinyur Wawan Gunawan Akadir MS, the Vice Rector for Research, Development, and Partnership of Universitas Pertamina, to deliver his speech. Prof. Wawan, the floor is yours.
Thank you, Mbak Gina. And Honorable Professor Toshifumi Matsuoka, and then Professor John Kaldi, and also Professor Budi Sucipto. He is the Vice Rector of Academic of Pertamina University, and then also now he is as the acting of the Rector Pertamina University. And all of the attendants, distinguished guests, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh, and good morning. Firstly, actually, I would like to say thanks to Professor Toshifumi Matsuoka. He is from Kyoto University and then also honorary professor in ITB, and also he's the head of Fukada Geological of Japan. And then also to Professor John Kaldi. He's from the Adelaide University, Australia, and also he is as the honorary professor in ITB. So both of you is the honorary professor in ITB. And especially for your spend time to be with us in this upbringing webinar. With title, of course, about the CCS and CCUS activity relating with the transition energy until 2060, I think Indonesia, because Indonesia, especially Pertamina, will set up net zero emission in 2060. This is an honor and great time for us, and also for the Pertamina University, and especially for me, because we meet again in another activity and another my position, because I think more than 20 years we met with the Professor John Kaldi and Professor Matsuoka in many positions. In 2000 until 2010, in that time I was as the dean in one of faculty in ITB, and then the last 10 years we worked with the Professor John Kaldi, and Professor Matsuoka is as the Vice Rector in Institut Teknologi Bandung. And now we meet with you as the Vice Rector in Pertamina University. So this is really nice. And yeah, we know that we are, especially myself, Professor Matsuoka and Professor John Kaldi, work together as well since 2010, I think. Yeah, relatively hard to work in CCS and CCUS in Indonesia. And now I think we are in the good time to realize that our dream project, hopefully, we will start with the initial CO2 injection in 2024 in the Gundi pilot project. And then I just would like to inform to both of you, Professor John Kaldi and Professor Matsuoka, the AGR CCUS in the Papua Tangguh gas field just assigned by SK Kamigas in the Ph.D. Project. So it's mean that that project will be as the cost recovery from the government. And then today, I think we are so lucky to have both of you, Professor Matsuoka and Professor John Kaldi, to share your expertise to all of us. I know if we are talking about CCS, CCUS in the world, your name absolutely will be in the list. When you trace in Google trace, something like that, and you ask about the CCS, CCUS, your name will be there. So according with that, hopefully more than, I think, it will be more than 200 attendants that come from lecturer of Pertamina University and from another institution in Pertamina Holding can learn and get a lot of information relating with the CCS, CCUS activity globally. Before I close my speech, as I discussed it with the Vice Rector for Academic of Pertamina University, Professor Budi Sucipto, now as the representative of Rector of Pertamina University, I'm so happy. I'm so happy if Professor Matsuoka and Professor John Kaldi in the next time could spend your time to be as guest lecturer in Department of Geophysical Engineering and Geological Engineering. It will another good time actually for us. Once again, thanks to Professor Matsuoka and Professor John Kaldi to be here and to all of you to be as the attendants in international upbringing today. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Prof. Wawan, for the speech. Now, I would like to welcome and hand over the agenda to Dr. Farah Mulyasari, ST MSc from Department of Communications under the Faculty of Communications and Diplomacy to introduce the session. Dr. Farah, the floor is yours.
Thank you very much, Magina, for your nice introductions. Honorable professors, Professor Toshifumi Matsuoka, Professor John Kaldi, and also our university leaders, Vice Rector of Academic, Professor Budi, and also Professor Wawan, as Far Rector of Research and Partnership. Very good morning to you, and also dear participants, dear students, lecturers, ladies and gentlemen. Thank you very much for coming today for our today's sessions in upbringing. Please allow me, my name is Farah, to moderate this upbringing lecture today to you all. And today we have, as have been mentioned before, the theme that is most important since we are emerging the world to zero emissions, and is related to carbon capture and storage, especially in Indonesia's energy transitions. So we believe that in order to meet the growing Indonesian demand for energy, while also constraining carbon dioxide emissions, carbon capture and storage, CCS, actually is gaining more attention. As an example, for example, to ensure the sustainability of existing business lines and also to address the environmental issues, state-owned company in Indonesia, such as PT Pertamina, as state-owned oil and natural gas corporation will be implementing very soon the CCS technology to reduce the carbon emissions as part of the enhanced oil and gas recovery efforts. So in order to that, PT Pertamina also has the interest as well to increase the country's oil and gas productions. So developing carbon capture storage at the power plant or industrial facility generally actually entails three major steps. I think our professor will be also talking about the process of capture, transportations, and storage, and several technologies that can be employed in the CCS process. So that's why in this opportunity, this international upbringing will also present on the future for petroleum and jobs for petroleum professionals. I believe Professor Kaldi will be talking more about that to give us the insights, maybe inspiration for our students in Indonesia's energy transitions, as well as carbon capture and storage technology. So to begin with, we will start with the presentation sessions from our both professors. The first speakers is Professor John Kaldi, and then followed by Professor Toshifumi Matsuoka. Your time is allocated for 20 up to 30 minutes speech. So I think you have lots of materials to share with us today. And can the committee display visualize the the short bio for both for our professors as the speakers? Yes, thank you. So the first speakers, can we have the next slides, please? Yes. Our next speakers is Professor John Kaldi. Professor John Kaldi is an Emeritus Professor at Petroleum, Geology and Engineering at the Australian School of Petroleum and Energy Resources in University of Adelaide, Australia. Professor John received his bachelor and master degrees in geology from Queen's College in New York and Ph.D. in geology from Cambridge University in UK. So Professor John Kaldi is also the CO2 CRC distinguished scientist and holds the South Australian State Chair in Carbon Capture Storage and CCS. So I think in the question and answer sessions, we can learn a lot from Professor John Kaldi. And as I also been previously mentioned before by both Professor Pak Budi and also Pak Wawan, Professor Budi and Professor Wawan, that Professor John Kaldi is also an adjunct professor at Institut Teknologi Bandung, Indonesia, and as a visiting professor at University Teknologi Petronas, UTP in Malaysia. And we hope soon that Professor Kaldi will also visiting us again. We will be delighted to have you as visiting professor again in our beloved university, Universitas Pertamina. Okay, thank you. I think we saw the thumb ups from Professor Kaldi. I think we are a bit running of time, so therefore, without further ado, I will give the stage to you, Professor John Kaldi, to deliver us this speech for today's morning session to begin with.
Okay, thank you very much to all of you who have been so kind with your introductions. And I'd like to say selamat pagi, selamat siang to all of our participants. Can you hear me?
Yes, loud and clear.
Okay.
Perfect. Yes.
Can you see my share screen?
Not yet. Maybe.
Okay,
it will appear in a few seconds.
Let's try that one. Is that visible to you now?
Yes, perfect, Professor. Please, time is yours, Professor.
Thanks. So again, I'd like to thank everyone for inviting me. It's a real honor to be able to be giving this presentation. I speak very often to students about different topics, and I find that the number one question I hear back from students is, will I get a job in my field of study when I graduate? Now, most of you who are at the University of Pertamina probably got into it because you were interested in oil and gas and wanted to get a job in that field. So I'm sure that your question is exactly the same. Will I get a job in this field of study? So let me give you the answer. The answer is two parts. First one is you must understand the law of supply and demand. And secondly, you must carefully plan and carefully manage your career. So on supply and demand, very simply, if supply exceeds demand, prices of whatever the commodity is, will drop. If demand exceeds supply, the prices of that commodity will increase, and oil and gas is no exception. Supply and demand rule number 2. If supply exceeds demand, job availability decreases, and we are seeing that right now. If demand exceeds supply, job availability increases, and we've seen that in the past, and we'll probably see that again in the future. You can look at it as a bit of a sine curve with dates in here because these are actual employment versus time plots, where there was growth in our industry and a very, very good rosy prediction until we had a retrenchment, which was part of the crash, and then we had rebirth, didn't know where it was going, but then again, we had a crash and retrenchment. Well, you know, this is part of the business cycle, typical of today's global industries, not only oil and gas. Well, are we seeing the end of the oil age? Is this meaning the death of a career in petroleum? That's what I'd like to investigate with you and Professor Matsuoka-san today. First off, the world population, despite COVID, is increasing, which means that the world's primary energy consumption is also increasing and projected to be increasing. Where's that energy demand? And you can see that the majority of the demand is really right here in the Asia Pacific region. And take a look at the makeup of that energy demand, mainly coal, natural gas, and oil. Renewables, small sliver of yellow, nuclear, small sliver of orange, and hydro in blue. Let's look at it in another way. This is from the BP Statistical Review of 2016. The yellow line is world energy demand, projected starting from about 1910 and projected right up to the end of this century, 2100. The thing to note is that even at 2100, which is, almost 80 years from now, the best estimates are that we will be seeing at least half of our energy needs met by fossil fuels. Yes, there's going to be an increase in solar, wind, geothermal. Yes, there's going to be an increase in nuclear, but there's still at least 50% going to be met by fossil fuels. Well, what does that mean? Take a look at your lifespan, or in the industry, your career lifespan, which is about here. And according to this, if we're going to be requiring so much of our fossil fuels, then careers in the oil and gas industry will remain significant. What about renewables, you might say? Let's think about renewables. Well, the sun and the wind, yeah, those are renewable, but solar panels, wind turbines, and batteries, unfortunately, are not renewable. Here's a solar farm in the Netherlands, and you might wonder what goes in to a solar panel. Well, plastics, glass, arsenic, hydrochloric, hydrofluoric acid, metals, aluminum, copper, cadmium, platinum, rare earth minerals, gallium, germanium, indium. By the way, 96% of the rare earth minerals are mined and refined in one part of the world, in one country, China. Plus, don't forget that in order to produce these, electricity, heat, and the resulting carbon emissions are going to be very, very significant, and they will have a fairly large carbon footprint. Well, what about wind? Here's a picture of one very close to where I am, Victoria. So what are these made of? Well, plastics, fiberglass polymers, which are all petrochemical based, concrete, which is cement, and carbon fibers. Again, metals, aluminum, copper, iron, and steel, plus the electricity and thermal energy, which will leave a very large carbon footprint. Batteries, well, critical raw materials, lithium ion, cobalt, lithium, cadmium, graphite, manganese, and nickel. Where do these come from? Well, mainly from the Congo, refined in China. Lithium, Australia, Chile, Argentina, refined in China. Cadmium, mined and refined in China. Graphite, mined and refined in China. Manganese, mined in South Africa and Australia, refined in China. Nickel, well, here's something that's mined in Indonesia, Philippines, Russia, and Canada, and probably refined in those countries as well. So there's an issue here with where we're going to find these resources, and is it appropriate to have all of those resources linked to just one major source? I'll let you think about that. What about copper for the transmission of our electricity? Here's one mine, okay, producing 50,000 tons of ore per day, and we will need about 100 times that much in order to meet the needs of our energy transition. So let's take a look at the scale on this. It's pretty big. Oops, that's not in focus, but these are about 15 meters high benches. There's a person to scale and walking over to the little rig. Okay, so just to give you an idea of scale. And this one, just to remind you all that, the oil and gas industry produces products that are more than just petroleum. Everything you see in this image, except for the people, of course, are made out of a hydrocarbon product. So if we're going to leave the hydrocarbon business behind, say goodbye to all of these products. And I don't think any of us are ready for that. So all of these things, and I won't read them to you because you can read them yourself. The only one I did want to show you is in the medical field, things like heart valves, vitamin capsules, the anesthetics, artificial limbs, bandages, gowns, surgical syringes. Did you know that the best estimate for countering the COVID pandemic is that we will require somewhere between 4 to 6 billion, 4 to 6 billion with a B, syringes in the next 3 years. Where do those syringes come from? Well, they're plastic, so they're coming from petrochemicals. And then, of course, we've got to transport all of this material from the manufacturer to the consumer. So I showed you this picture in a moment ago. There's one other component of this that I think we need to keep in mind, is that as we're producing these petroleum and coal products, our greenhouse gas generation is going to remain significant. So can we have a petrochemical and fossil fuel industry yet maintain a manageable greenhouse gas emission in our planet? And I think the answer is yes. And part of what many of you might be doing in the future, in addition to your interest in petroleum, is to help save the planet by doing carbon capture and utilization and storage, abbreviated CCUS. So let me take you through a very simplistic rendition of what that all means. Well, those of you who are chemical engineers will probably spend some time working on CO2 capture and separation. Mechanical engineering folks will probably get involved in the surface facilities and compression and transport of the CO2. Those of you in the drilling side of the business will get involved in drilling wells for CO2 injection and CO2 monitoring. And reservoir engineers and geoscience folks are going to have a lot of input in the actual CO2 storage. The CO2 storage is the component with the greatest uncertainty. Why? Because we really don't know all that much of what's in the subsurface, and we're dealing with thousands of meters below the surface if we're serious about putting CO2 away. So there's a lot of uncertainty. So reducing that uncertainty with the geological storage requires certain skills. It requires exploration, site-specific studies that will include things like reservoir characterization, geochemistry, geomechanics, modeling, monitoring, running economics, and running risk analyses. And guess what? These are technologies used commonly by the petroleum industry and that are being developed for CCS through demonstration projects. We are at the moment looking at over 100 demonstration projects around the world and over 20 commercial scale, by commercial scale, more than about 800,000 tons per annum of CO2 that is being stored. So we're learning by doing. One of the most important things to remember is in terms of scale, most of the public views the world up here. They don't understand that when you're putting CO2 into the ground, it's not just a meter or two away, it's very, very deep down, thousands of meters, and we don't fully understand, but we're doing a much better job, thanks to the petroleum industry, of understanding what is down there. So, can we incorporate the knowledge from petroleum into CO2 storage? Well, I think we can. I think, in fact, that sustainable petroleum development is going to be based on our utilization of carbon capture, utilization, and storage. That's going to give us a viable and optimized industry, both in the exploration development facet and in enhanced recovery. And this is from Denise Cox's presidential address in 2019. She's the president of AAPG. I mentioned that there were 20 some odd large-scale CCS projects. Well, here they are. And these are pretty much producing viable emissions reductions by putting in at least 800,000 tons per annum into permanent geological storage. So I think that we are seriously considering the world of the future as being a carbon-constrained world. We all know that this is an environmental necessity, and judging from what's going on with politics and the social media today, it is a socio-political reality. But let me ask you, can CCS or CCUS also be a business opportunity? Well, I think we're fairly certain that there is a carbon price and emissions trading with not if, but when, and of course, how much value will there be on carbon? CCS has recently been recognized as a clean development mechanism by the United Nations Framework on Climate Change. What is a CDM? It's a clean development mechanism that allows developing countries such as Indonesia, who are instituting or implementing CCS, to receive funding from the UNFCCC, and their budget is not just a few $1 million, but it's in the hundreds of billions of dollars. Of course, we have enhanced oil recovery, enhanced gas recovery, and enhanced coal bed methane as CCUS options in the world. But look, there's still many issues to consider, and we can touch upon some of those. And Professor Matsuoka-san will also touch upon many of those. We know that the carbon-constrained world can rely on a resource-style business model. And one of those is the enhanced oil recovery, where we take carbon dioxide, inject it into a reservoir which has residual oil saturation. Of course, this is not to scale, this is thousands of meters deep. Inject it with water as a drive mechanism, and form a miscible zone where the oil is produced, the additional oil recovery, and then we can strip out the CO2 that comes up with the oil, and that's only about 25–26%, re-inject that. So we're recycling our CO2. That's 74–75% of the CO2 that isn't recycled, of course, stays in the formation as permanent storage. So one of our business models, of course, is that EOR. But there's more. Pore space, whether the state or private individuals, and it depends on the nationality, the nation, whether individuals own the pore space or whether the country, the government, the state owns the pore space. But that pore space is going to be a commodity, which means exploration plays and prospects and permitting, acreage releases, reserve certification of pore space, unitization and equity determination, big development and infrastructure needs. We'll have to put regulatory regimes and legal liability issues in for that pore space. But it is a business model. Let me give you an example. Recent article from the Petroleum Exploration Society of Australia. 2 companies signed a strategic agreement for decarbonization exploration. What does that mean? They are looking for pore space. Another example, this is Santos's local oil and gas company here in South Australia. They decided they're going to do carbon capture and storage. It's FID ready, and it's going to be eligible for Australian carbon credit units, which is expected in the 4th quarter. So that's onshore. And then, of course, their latest discovery, sorry, let me go back to that. because the Mumba area is presently emitting 1.7 tons per annum of CO2, and Santos's Mumba project is expected to put all of that into the subsurface, well, at least 95% or more. Santos also recently took over the Barossa field, and they're assessing the feasibility of a CCS hub at Bayou Undan with a capacity of almost 10 million tons per annum of CO2. That's going to provide a cost-effective solution for the emissions, providing a carbon neutral LNG project. And this is very, very important. Carbon neutral LNG could be part of not only theirs, but other nations' roadmap to net zero by 2040. And Professor Wawan mentioned the Tangguh project. Well, the Tangguh LNG project or Tangguh gas production could also be leading to net zero and carbon neutrality. Well, CCS is a career. Let's think about that. We know that the global response to climate change is going to include a whole range of different mitigation measures. That's going to include greater efficiency, more renewables, lower carbon fuels, and CCS. There's no silver bullet. There's no single answer to how we're going to respond to the climate change and global warming. Let's be very, very clear about that. The other thing we need to be very clear about is that we're going to continue to use fossil fuels. So we need to learn to do it in cleaner and smarter ways. And you know what, ladies and gentlemen? CCS is the best option we have at the moment for doing this. Commercial deployment of CCS is going to foster an industry equal in size or larger than the present oil and gas industry. That may be very, very difficult for you to believe, but if we're serious about it, that's the scale we will need to bring in. It's these 100 or so demonstration projects, plus the existing projects. And by the way, you've got a great demonstration project at Gundi, which Professor Matsuoka is going to talk about, I hope. This demonstration projects are going to provide us with confidence that CCS is actually technically feasible, and that'll help accelerate its commercial deployment. The important thing for you folks to remember is that CCS will require skills in engineering, skills in geoscience, skills in economics, legal, regulatory areas. It's going to offer broad career opportunities for those prepared for this new technology. Okay, how do you prepare for this new technology? Well, now we have to dig a little bit deeper into what is it that actually happens as part of the subsurface skills required. Well, understanding the key criteria for storage site selection is critical. Three things. We need to understand injectivity, which is basically answering the question of, can we actually put the CO2 into the rock? What is the capacity? In other words, what volume of CO2 can the rock hold? And containment. Can we actually keep the CO2 in the rock without allowing it to escape? So those are the three areas that geoscience and reservoir engineering can really contribute. That site selection, site characterization is basically fundamental skills that we learn in reservoir characterization. And these skills are so easily transferred to CCS by data integration to help us model reservoir, seal architecture, and flow properties. And I've shown some of these things here. We'll use seismic visualization, injectivity modeling, cap rock studies, geomechanics for fault characterization, integrating production data, geostatistics, reservoir optimization. What are we doing? Well, we're simulating the reservoir properties and determining volumetric storage capacities, all fundamental to the CCS business. So managing your career. Be flexible. You've heard this. If oranges aren't selling, sell bananas. Change your focus. Here we have, again, that sine curve showing the growth, the retrenchment, etc. But now let's look at it in a slightly different way. That growth retrenchment cycle goes with each industries, but these industries are not in sync. Which means if we can predict when discipline A is going to go on a decline, maybe we can jump over to discipline B. And when discipline B starts on its decline, maybe we can rely on a timely change to discipline C. So this is the timely career change. So think about your career now. Your career can take many directions. It can go beyond oil and gas. And it's only you can set those directions. It's not that easy. I'll be very honest with you. I'll show it to you in a slightly different way. Two geologists see a tiger. One geologist says, let's run. The other geologist says, we can't outrun a tiger. The first geologist says, I do not need to outrun the tiger. I only need to outrun you. You know what, folks? We are in a competitive market, whatever that career we choose will be. So to establish a career in oil or gas or CCS, or for that matter, any industry, and to survive in that career, you must be better and judged to be better than your peers. I'm sorry to say this. It is a competitive world out there. How is that judgment made? Well, first of all, your career is based on how well you apply yourself. This is your technical skill base. How well do you work in teams? Very, very important. And how well are you engaged with your professional discipline? Are you a member of professional societies? Do you go to talks? Do you read the literature? Are you familiar with the leaders in the field? That's engagement. So those are all ways that your management will be judging you, whatever discipline you're following. The recent AAPG Explorer this month, August 2021, says geoscientists will be the backbone of the energy transition. It says the future for a petroleum geologist, geoscientist might seem more uncertain as the transition to cleaner energy begins. Few students have their ambitions set on oil and gas, and industry professionals are beginning to question how their knowledge and skills will fit into the world of new energies. But let me assure you that geoscientists will be needed in the future to help identify and develop things like geothermal, as well as the sites for CCS, as well as hydrogen storage, and even storing byproducts of nuclear. Right now, we've got a pressing need for geosciences, unique and detailed knowledge of the subsurface, as all the countries, nearly all the countries who've signed on to Paris Accord rapidly ramp up on carbon capture and storage projects to reach their global emissions goal of net zero by 2050. And Indonesia is right there as well. So advice to you as potential future CCUS professionals. Consider CCUS when choosing a career path. CO2 storage is a frontier industry. There's still plenty of opportunities for growth here. You know, there are no majors or super majors in terms of CO2 storage yet. Okay. Addressing the impact of CO2 emissions on climate change is going to require a workforce of scientists and engineers who are creative and intelligent. And that's you guys, I know it. And no other entity understands the subsurface reservoirs of the world better than the geologists, engineers, and other scientists working for or studying for the petroleum industry. Don't be afraid to get your hands dirty. Work with the actual rocks. Look at the rocks, look at the data, and find out what we're trying to understand and characterize to achieve the goal of net neutral carbon emissions. And that really is all I had for you. I'm happy to answer questions either now or at the end of this presentation that we're all sitting through today.
Okay, thank you very much, Professor John Kaldi, for your valuable and also inspirational talks for us today, for our dear participants, for our students, and also for our lecturers today. Very much rich informations about talking about the carbon consent world, and also your inspirational talk about the future of CCS professionals. I believe there will be a lot of questions, but please, dear participant, you may raise your questions after Professor Toshifumi Matsuoka will present the lectures for us today. Thank you very much, Professor John Kaldi, and I will get back to you in a few minutes afterwards. Okay, thank you very much. Okay, so the next speaker is Honorable Professor. We have here already to welcome Professor Toshifumi Matsuoka. Hello. Genki desu ka, Matsuoka Sensei? Nice to meet you again.
Can you hear?
Yes, yes,
Okay.
I can hear you clearly. But first of all, I think for the introductions, you already been introduced.
Okay.
Yes, by Professor Wawan. Yes, but yes, please, Sensei, go ahead. Yes, the time is yours. So, but please allow me for a few seconds to introduce you to our participants today. That Professor Toshifumi Matsuoka is professor and emeritus professor from Kyoto University. So we have actually been known each other for a few years, right, Matsuoka Sensei? And nice to meet you again, to welcome you in our beloved university. Yes, and Matsuoka Sensei, or Professor Matsuoka, is also honorary professor at Institut Teknologi Bandung in ITB Indonesia, and we hope that in the future you will also visiting us the chance to meet us in Universitas Pertamina. Okay, without further ado, I will give you now the time and floors to explain and also to give your lectures to all of us. Please, time and stage is yours. You have approximately 20 maximum until 30 minutes.
Okay.
Okay.
Thank you. Thank you very much for the kind introduction. I want to share my slide. And wait a minute. It's okay.
Yes, we can see.
Can you see?
But yes, in presentation mode, please. Yes. Mm-hmm.
Okay.
Yeah. Next. Perfect.
Yeah.
Say, yeah.
Thank you very much. I'm Toshifumi Matsuoka, and I have been working so many times with many friends in ITB, professors and students. We have been working for the Gundi CCS project. It's around more than 10 years. So I hope within few years, this project, the Pertamina, I want Pertamina make a FID to this project. Okay, So today I would like to talk about CCS technology. So first of all, I would like to start the transformation into decarbonization society. Okay, this is very once a famous pictures. It's last year, 9 September at San Francisco. So this red looks like a everywhere red. This is mean the sunlight, short wavelength light cannot reach up to the surface because the wildfire, the many small particles stop the short range light. Okay, therefore the lady is jogging in such a world. Okay, on the right hand side, this is the picture I borrowed from the Nature's paper. So this is a North Pole, and you can recognize so many red or orange dot. These are wildfire at the North Pole area. So it's as you know, it's North Pole is so cold, and it's so far we believe there's no wildfire, but now its situation is changing. As you know, it's IPCC 2021 report is published last week. So this is climate change 2021. And the conclusion is the following. It is unequivocal that human influence has warmed the atmosphere, ocean, and land. So widespread and rapid changes in the atmosphere, ocean, chronosphere, and biosphere has occurred. So we want to stop climate change. So in order to stop climate change, we need to make a decarbonization world. So from this pressure, many oil companies mentioned their basic strategy, how to protect the climate change. So as you know, it's a BP, Shell, Total, ExxonMobil, Chevron, and I put one company, Impex, because Impex is a Japanese company and also working in Indonesia. So, and also I classified 3 classes of these major oil company. One class is a green company. The second class is blue company. And the last one is a black company. This is because these green company mentioned or opened their strategy to CO2 reduction target at 2050. For example, BP and Shell is almost same strategy. By 2050, reduce CO2 emission in the production process to net zero. So that means no more flare and also no more methane leak. And also in the case of platform or refinery plant, they try to use renewable energy. No more, how to say, it's the hydrocarbon burning. Okay, and also reduce CO2 emission in the consumption process by 50% by 2050. So that means BP will continuously sell oil and gas is only 50%. What is other 50%? So I guess, this is my opinion, I guess they will start to sell hydrogen instead of natural gas. So that means the As you know, we can make a hydrogen from natural gas. So put CCS technology. So that means the decarbonization energy resources. Okay. And main initiatives, investment in low carbon project and carbon offsetting, and also CCS. Okay, this is important. So reduction of CCS emissions through CCS and reforestation. Okay, and renewable energy, biofuel, and hydrogen use. The next class is total and impacts, I believe. So reduce net CO2 emission by 25-35% in production and consumption stage by 2040. So main initiatives, CCUS, yes, this is a main tool. And okay. And in the case of impacts, they committed reduce CO2 emission in the production process net zero, I think by 2050. That means, yes, this is the same statement, no more flare, and they need to use new renewable energy. And also there is a terminology is CCS exists here. And the two companies, two big major companies, ExxonMobil and Chevron, they did not mention detail, but reduce CO2 emission in production process. But they are considering CCS and also conducted R&D on biofuel. Okay. And as we know, the Chevron is doing very large CCS at the LNG project in Australia, that Gorgon project. So all these initiatives may contain the CCS or CCUS. That means for these oil companies, they start to, how to say, to build new technology of CCS. So I would like to say, don't worry your job in future in oil company. This is the same message from the Professor John Kaldi. Okay, what is CCS? So the only CCS is the only technology available to mitigate greenhouse gas. This sentence comes from the CO2 capture and storage IEA published 2008. So this is the concept of CCS. Maybe you know a little bit about this idea. CO2 source, capture, transport, and storage. So generally speaking, there is a two sides we are trying to inject. One is CCUS, that means CO2 The other one is deep aquifer. Okay, so there are two candidates for CCS, aquifer and depleting oil field. So this is a CO2 However, finding the good CCS reservoir is not easy. So this is the characterization, or how to say, the selection of CCS site. Why? Because I compare to the oil and gas activity and the CCS activity. In the case of oil and gas, exploration target is structure and stratigraphic trap, as already you know. However, in the case of CCS, our target is deep aquifer. So this aquifer is hydrogeologically homogeneous. That means continuous, connected, and widespread strata. So this is a very nice CCS reservoir. And how to find this target? In the case of oil and gas, we have quite many know-how accumulated through long exploration history, such as oil system, direct hydrocarbon indicator, ABO, and so on, so on. But CCS case, there is no such different fluid exist in our target. So therefore, almost no, we have no know-how to find a good deep aquifer. Since this CCS activity is very short time, no experience. And one thing is a fault is sometimes it's different treatment. Fault is considered as a seal. However, in the case of CCS, many people is I'm saying is sinking. Fault is considered as a leakage path. So the last one is, I believe, it's important issue. In the case of oil production, amount can be controlled by secondary recovery, IOR and EOR. However, in the CCS, injection amount is controlled by pore volume and injectivity. So capacity and injectivity. But we have no idea how to improve the injectivity. So I think this is, we need to develop a new technology to improve the injectivity. For example, how to use, for example, it's a micro bubble method or surfactant, putting some chemical in the CO2. So something like this area is completely new field, and we need new development and research project. And how amount of the CO2 reduction your IEA is asked to CCS? It's around 2.5 gigaton. So this is a kind of big number, and also time is limited by 2050. So many people ask, is this plan feasible? So I'd like to say yes. The two scientists published last year as a Nature scientific report, last 2019. So look at this global offshore resources. So this area has big, very large sedimentary thickness, like a Gulf of Mexico and North Sea and the west part of Australia and Indonesia. So this area has big potential to the CCS site. So it's only in the case of Gulf of Mexico, there exists 4,000 offshore platforms. So if one platform can inject the 1 million ton per year, it's enough for the 2.5 gigaton CO2 reduction. So this also calculated prediction of CCS well number based on the oil field development history in Gulf and North Sea. So this line is the history of Gulf Coast oil field development history. Just starting from 2020, 2050, the Gulf of Mexico, this means we can drill more than 10,000 wells. So, and this solid line is corresponding is the injection, cumulative CO2 injection amount. So in 2050, the Gulf of Mexico is a yearly 12 gigaton per year, may be able to inject, and cumulative is 116 gigaton. And also North Sea is yearly 7 gigaton. This number is predicted by these two authors. So somehow this is a large number, but we can solve our problem if we use Gulf of Mexico and North Sea. So, and next topic is recent activities of CCS. I would introduce a new business model and CCS bubble economy in United States. So as you know, Norway is a leading CCS country. So it's one example is Sleipner. They started in 1996. And now they are considering the new, very interesting project. Okay. First of all, this is an example of large-scale CCS project. The world first aquifer storage from 1996. Operator is Equinor, and 1 million tons per year they are injecting. And the reason is at Norway to avoid environmental tax. So the Norway government asked to Equinor 1 ton if they release CO2 to the atmosphere, asked to about $60. So injection activity is more cheaper than this amount. So this is, as you know, in the seismic section, we can clearly recognize CO2. Okay. And this is a recent trend of CCS project after Paris COP24. These are corresponding the year. Now is the 2020. This is the 2010. This is the one peak we can recognize is a 2011. The red is already operating, and the upper part is a plan. We have so many plans, but this is a fast boom and then decreasing. However, after Paris COP24, many people is considering new plan. So present, we are injecting 40 million tons yearly, but our target is 2,500 million CO2 per year at 2050. So, but in the case of large CCS project, sometimes it's a difficulty, is a financial difficulty. Therefore, is many CO2 EOR. If without CO2 EOR, we need other incentive like a carbon tax. This is a Sleipner, carbon credit, or subsidiary, or regulatory requirement. This is kind of the gorgon. So, however, this project is Norway government is planning, and very interesting. I believe this is a new business model, Northern Lights CCS project. So it's one of the large commercial CCS in Northern Europe operating by the Equinor, Shell, and Total. The idea is they prepare one CCS site, and they accept around 35 potential customers in Europe. These customers is producing CO2. They capture this CO2 and to transport by ship, and this company accepted this CO2 and try to inject this site. So this is very supported by Norway government. And also the 2024, they want to start 1.5 million tons per year. And by 2030, they want to ask 30 or to $55 per ton to these customers. So this is a 100% commercial-based large CCS project. And on the other hand, in the United States, there are regulation and subsidies. So it's they are starting so many CCS planning. So incentive is West Coast LFCF market and also 45 tax credit. So it's now it's a U.S. federal government 45Q tax plan. This is if the person to do CCS, the tax credit provide $50 for CCS and $35 for UR. So it's a very large incentive to start CCS. And also in the case in the California state, they made low carbon fuel standard. So this system is California government asking to use biofuel. And if they do not use biofuel, they ask to buy some carbon credit. So therefore, it's in California, carbon credit is selling and buying. So this graph is the price of carbon credit. So it's increasing 2019, the carbon credit price is almost $200. So that means if we do CCS in United States, $50 from the 45Q tax credit and $200 for the LSCF. So this company is not oil company, not energy company. This red trial energy is producing the biofuel from the corn. So they started CCS project, and I believe actual injection will start to 2023. So already they drilled several wells for injection and monitoring wells. So this is a new trend. And finally, I would like to show from Nagaoka project. This is a very slow project, small project, but we get several knowledge. So this is an overview of the injection site. This center well is the injection well, and they drill a 3 observation well. Now this is a injection well, and this is observation well. It's only 40 meters, and this is another well, and this is another well. So the total amount is 10,000. It's very small CCS project. So it's considering to the CCS technology, I believe this trapping mechanism is very key concept. So trapping mechanism is, we classify as 2 parts. One is a physical process, the other one is a geochemical process. And physical process is contained 2. One is mobile CO2. So this part is oil and gas industry people is well known, very familiar. So horizontal axis corresponding to the year, and then this mobile CO2 becoming not immobile or solving the groundwater, and finally mineralize. So today I would like to pick up this residual CO2 trapping issue. So this is a highly related to the risk profile. This is years, the start of an injection. The risk is increasing, maybe exponentially or a straight line, whatever, and then kind of some steady. Once we stop the injection, this risk curve is decaying. But how to control this curve? This is a very important issue because it depends on how long we need to do monitoring in the CCS site. So compared to this data, this is the injection history and pressure response. So it's a start at this time. The pressure of the injection well, bottom of the injection well is red line. We build up about 2 megapascal large pressure and start injection. And this blue line is corresponding observation well pressure. So observation well pressure is also increasing. But once we stop the injection, this curve decaying so quickly, like exponentially. So that means that this curve, basically this curve controlling the risk decaying curve. And this project, we get many interesting observed results. Again, horizontal axis is corresponding to the time, is days. We started here injection, and we stopped the injection up here. So this is a observation where 2 is 40 meters far from the injection well. So after injection, around more than 200 days, we measure the CO2 because CO2 is resistivity is a large number. Okay, this green zone is a reservoir target. And this upper part is maybe CO2 is migrate more shallow or sand layer. But the more interesting is this red part. So this part is low resistivity value is corresponding to the CO2 dissolved into the groundwater. Therefore, resistivity is lower number. So clearly we can see this is a dissolves groundwater CO2. Yes.
Excuse me, Professor, you
Yes.
have a couple of minutes left.
Yes.
Thank
Sorry,
you.
this is in the residual trapping mechanism is quite interesting. As maybe you know, the residual trapping is this CO2 cannot pass through this road because capillary pressure. Capillary pressure is more larger than buoyancy pressure. So it's this is the saturation of CO2 is where BO2 is this saturation is up to 40%, but to stop the injection, this saturation is decreasing, but this is almost a stop. So far, we are thinking this effect is residual trapping. But the upper part, this is a deep direction is this way. So more up deep well is increasing saturation CO2. So it's I'll just summary my talk. CCS and CCS are key technology for sustainable development. And historically, CO2 was developed in the United States quite a long time ago. And then CCS had followed. I believe in Indonesia, maybe they follow the same history. Indonesia starting CO2, and then step by step, CCS will start it. Okay, and the CO2 trapping mechanism is important to CCS risk consideration. There are plenty space for technical development and innovation of CCS new technology. And of course, it's appropriate regulation drive CCS, CCUS activities. Okay. Thank you very much for your attention.
Thank you very much for your great presentation and talks, Professor Matsuoka. Thank you very much. Arigatou gozaimashita.
Thank you.
Okay, so yes, we will enter now the most exciting sections of our upbringing session today is the discussions, questions and answer forum. So I think each of you, the participants, has already questions in their mind. But to begin with, I would like maybe to follow up to Professor John Kaldi. Please, I think you were talking about much more career for our future students as the graduates. So how do you think the challenges here in Indonesia in terms of CCS, and how can we better prepare our students and professionals towards CCUS for decarbonization world? Professor Kaldi.
It's a very easy question to answer. Just continue doing exactly what you are doing with helping them understand subsurface processes, understanding geology, understanding fluid flow, understanding geomechanics, understanding volumetrics, and how to calculate all these. Those are the key principles that will be required. So a good fundamental knowledge of the subsurface is what we will need for CCS.
Yes, I believe our lecturers also attend these upbringing lectures, and we will prepare our students as per your suggestions how to much more further develop into the Indonesia's energy transitions, because so far until now, maybe we don't know about the future, but until up to now, CCS is the best methodology to reduce greenhouse gas emissions. Yes, Professor. Okay, so before having the questions from our participants, I would like to turn to Professor Matsuoka. Thank you very much for giving us and also sharing the knowledge about the project in Nagaoka. When we compare, of course, with the upcoming CCS project in Indonesia in Gundi, which we believe that we are optimistic it will be implemented very soon. Actually, in terms from the size, Nagaoka has you mentioned before, is smaller than the Gundi project. But do you think there is any key success factor that can we adopt it to bring this lesson learned in Indonesia as a pilot project for CCS Gundi be implementable?
Yeah. Yes, the Gundi project is not a large scale because it's yearly is around 300,000 tons per year, something like. So but I believe doing real CCS project, many engineers can learn so many things. Like, for example, it's like we expected CO2 inject is this amount. However, sometimes it's make us some difficulty. So then we consider the injection mechanism. This is already mentioned, Professor John Kaldi. So many engineer or student can find many problems in real CCS project. So it's just do and start. It's a very important issue in Indonesia, I believe.
Okay, thank you very much for your motivations and also endorsement to implement and to straightforward with our mission since a few years ago for Indonesia. So we will open now the question sessions from the participant. I believe there's a few people already would like to ask you directly in this forum. So we now open the opportunity for 3 questions from the chat box and also 3 questions first from the participants live here who attend the upbringing session this morning. Okay, to begin with, is there any from the forum would like to ask to our beloved Professor Matsuoka, and to Professor John Kaldi? Oh, okay, I already see the your hand already raised for Muhammad Izzat Pratama. Please, you can ask the questions.
Okay, thank you, Ibu Farah. Good afternoon, Professor John Kaldi and Professor Matsuoka. Let me introduce myself. My name is Izdihar Pratama Lubis, from Mechanical Engineering student from Pertamina University. So I was wondering, like every business need to make a profitable company, right? So I was wondering, like, how this CCS industry making profit. If I'm not mistaken, Professor Matsuoka explained that the profit is from tax. So the government giving the tax to the company. But what if the country didn't regulate the regulations to do that? And then the second one is
let's do one question at a time.
Okay. Thank you.
Okay. Whom you ask these questions to, Professor Kaldi, to Professor Matsuoka, or to both our professors?
Both of them.
Okay, thank you. So we can call you Izihan because your
Yes.
name is long.
Dihar.
Okay, Dihar. Okay, please, Professor Kaldi, maybe you would like to ask first, to answer first.
Sure. Look, there's two major mechanisms for getting value from CCS. Number one is by CCUS, actually getting a product that will make money, which includes things like EOR, includes things like the soft drink industry, pharmaceuticals, and all of those chemicals that rely on CO2. So there's money to be made. But the scale that we are talking about is much larger than all of the Coca-Cola, all of the fire extinguishers, all of the chemical products from CO2 that we can make. So we're really looking at EOR, possibly EGR, as a real moneymaker. The other option, of course, is the regulatory frameworks. So there could be two ways of doing that. There's a tax on carbon. So carbon emissions will be taxed. Those taxes could be avoided by carbon trading mechanisms. And we're seeing that in various countries. In the USA, in Norway, we've got a tax, which is the stick. In places like the USA, we've got a carrot, which is the 45Q regulations, which will give a company $50 per ton of CO2 stored as CCS and $35 per ton of CO2 that's done for CCUS in the EOR. So those are the main mechanisms. There's another one which is called regulating the ancillary operations. For instance,
it's not.
Let me just finish the sentence here. The ancillary operations, such as the Gorgon project in Australia, which at the moment is the largest CO2 storage project in the world, somewhere between 3 and 4 million tons a year. The reason that the operators, who are Chevron, Shell, and ExxonMobil, are doing it is not because of altruism, I'm afraid to say. It's because the government of Australia has mandated that in order for them to put together an LNG project on a Class 1 nature reserve, which is the Barrow Island, they passed the Barrow Island Act, which says there will be no pollution, on Barrow Island. So they regard CO2 as a pollutant. So therefore, the companies, in order to get their LNG project license, had to put CO2 away as sequestration. Anyway, so those are the different mechanisms that exist in the world. Carbon trading or emissions reductions trading is on its way, as I mentioned, and I don't think that there's any doubt in any of our minds that that's going to be one of the ways that Indonesia is going to be able to monetize its efforts. Anyway, Matsuoka-san, what have you got to add?
Okay,
Okay.
Sensei, please.
Yeah. It's basically, yes, the same opinion. So maybe Indonesia, you will start for the EOR, and then, but I would like to put one idea, because you are exporting to the natural gas to the around the world. For example, Japan, we are so much importing, but in future, maybe 2040, we import hydrogen instead of natural gas. You know, that means that your terminal will start making hydrogen using from the natural gas with CCS. All cost of CCS you can put on the cost of the hydrogen. So in Japan, we have no such, how to say, energy resources. We even is expensive, but I believe we will buy your hydrogen. So it's a more the set.
Yes, thank you very much, Sensei, for your answer. I think that answer your question, right, Dihar? Yes, so we will take an advantage of your suggestions for Indonesia to import more hydrogen in the near future. Okay, there are some few people already raised their hand. For example, we have here Rizky Abdillah. Could you open your camera, Rizky?
Thank you, but Bu Farah, I would like to apologize since my connection in my place is very bad. So
Okay.
yeah, I'm so sorry, everyone.
Okay.
So, hello, good afternoon, everyone. Let me introduce myself first. My name is Rizky Abdillah. I am a currently student from Pertamina University, majoring international relations in the grade 7 right now. So I'm focusing to finish my thesis right now. And actually, my thesis is very related with our topic this day. So my question is, as we know that carbon capture and storage, CCS, is one of the global warming mitigation technologies by reducing CO2 emissions into the atmosphere. This technology is the implementations of the processes that are related to each other, starting from the separations and capture of CO2 from exhaust emission sources, transportations of captured CO2 to storage. So this technology refers to the emissions reductions of power plants that come from fossil fuels. Indonesia, as one of the countries that are members of the Kyoto Protocol, can be considered very much in possession of power plants that come from fossils. Based on these explanations, will the implementations of CCS be effective in Indonesia, considering that CCS itself must be applied to all power plants that contribute a lot of emissions? And that's a lot for me. That's a lot of Indonesia that we can find a lot generator of fossils in Indonesia. So is the government will capable of that or not? So yeah, this actually not a typical questions asking more at the operations, but it's more likely on the government side. Thank you, sir.
Okay, thank you, Rizky, for your long questions. I hope our professor can pick up your main essence of the questions. Okay, to whom you're asked questions? To Professor Kaldi and Professor Matsuoka, both of them? Okay, maybe I will.
Who's the question to?
Hello, Rizky, are you still on?
Yes.
Yes. So could you repeat in short format what is your questions actually?
So based on these explanations, will the implementations of CCS be effective in Indonesia, considering that CCS itself must be applied to all power plants that contributes a lot of emissions? Thank you.
Okay, thank you, Rizky. So I think Professor Kaldi pick up that questions, right?
Well, I think that one is out of my scope of understanding, because you know, I cannot control what the Indonesian government does. I do not have a good feeling for it. I'm not sure anybody does, but it is one of those things that could be a recommendation from your universities. I'll say plural, because I think it will have more weight if it comes from Diponegro, Pertamina University, ITB, all the different universities as a recommendation. I think an important recommendation that is recognizable is something that our friend and your friend, Rahmat Sule and the Center of Excellence has able to produce, and a recommendation from the COE would be very, very valuable. I think the government is now in a position where it will be listening to such recommendations.
Okay,
Thank you
very
so
much,
much,
Dr.
sir.
Kaldi. Yes, I think Rizky, you
Yeah.
got answers right. So
Thank you. That's very tangible. Thank you.
okay, thank you. Maybe you want to add some more, Professor Matsuoka, or is it?
Okay. Yes, the many issues related to the cost of CCS. So it's like if we consider the coal power plant, is the cost is too expensive. We cannot do anything. But however, is now is the most expensive part is capture part, and of course it's pipeline part is already matured technology. But I believe it's the many people like United States, they are spending a lot of money for developing is capture technology. So soon or later, this price is more decrease. So so it's more easy to start the CCS, because in this is the same in Japan. The CCS, many people mention CCS is too expensive to start, but maybe new technology or a new innovation in capture area, we can start more easily. So that is my prediction.
Okay, thank you very much, Professor Matsuoka, for your answers. So I hope, yes, we do hope all in Indonesia that we can start within as early as possible and give a strong recommendations, and then calculating again the budgets and allocations for that to be more implementable in our country. So may I maybe shift to the questions in the chat box? There is one question refer to you, Professor Kaldi. So it is from Nana Setiawan, and he's asking about the enhanced oil recovery system usually utilizes a high pressures compression facility with an output pressures of more than 100, more, since the product will be injected into the reservoir. So is that possible for the CO2 product to be utilized as an oil recovery through the oil production pipe on the annual as well? For example, as a gas lift facility, meaning that there will be facility on the surface, facility for CO2 separations from the main oil product. This idea maybe will minimize the value of pressures and minimize the power requirement on the injection facility.
Okay, that's a pretty long-winded question, but I'll address it as best I can.
Okay,
so there's certain requirements for EOR, CO2 chemical flood EOR, and those are things related to the minimum miscibility pressure that the reservoir is at. You can't be too low a miscibility pressure, otherwise you won't get miscibility. You also need to be in a low enough permeability and lack of heterogeneity, because if you inject the CO2, even if you're at the right miscibility pressure, if you've got a very, very high permeability streak, all of your CO2 will go down the high perm streak, and you won't have a decent sweep efficiency. You also need to have a high enough residual oil saturation. If you've got a very low residual oil saturation, it's probably not worth the effort of doing it. So there are certain myths about EOR, which says that, oh, I've got an oil field, I can use it as an EOR project. No, you can't. The oil has to be a certain viscosity, the reservoir has to be a certain conditions, the formation pressures have to be at a certain way. So it's not quite as easy. But in terms of the surface facilities, you know, we have technology that could increase our pressures. We can do the separation. So that's not the real issue. That's something that is very easily surmountable. It's those other things, I think, that are the real factors to consider.
Okay, thank you, Professor Kaldi, for your questions. I hope it can be understood by Nana Setiawan. I hope I think Nana Setiawan or Nana is still here with us. So there is one more slot or opportunity to ask live to our professor. But today, from the participant, is there anyone else who wants to ask? Maybe Pawawan, you would like to add some more, and Professor Matsuoka? Oh, there is one question, I think it's believed from our lecturers. This is from Mr. Sahriza Angkasa. He's the lecturer in our Geological department. Please, Mr. Sahriza, could you raise your questions?
Yeah, thank you very much. I cannot turn on my videos because I have some trouble with my videos. I think I have a question, just one quick question. What is the fundamental basis of the reservoir in carbon capture storage? And when I was studying in Norway, we were working on CCUS, mostly working with CCUS, but they would like to inject all the carbon to the peridotite. So then it will make mineral reaction, so carbon reacting with some calcium on the plagioclase and creates calcite. What about that? I mean, terms reservoir that you gave to us is you have a aquifer, which is very different what we talked in Norway at that time. So can you give me some opinion from your perspective? Thank you very much.
Thank you, Mr. Sahriza. Maybe Professor Matsuoka first would like to respond to that.
Yeah, it's mineralization is related to geochemical issue. So I'm not professional, but maybe I can say some word. It's the mineralization is firstly CO2 is dissolved into the water. Then it's a last stage in mineralization. So far, we believe it's the time scale of mineralization is long. We need long time, as usually in the case of the sandstone. But in the special case, like volcanic rock, the geochemical reaction happens so quickly. So there is not yet I can say such an exact answer, but this is still some area to need to investigate. So, and where is the best CCS site? Yeah. And we need to consider such an issue to select the site. So this is okay to your question?
Okay, Mrs. Sahriza, can you hear respond
Yeah.
to Professor Matsuoka? Maybe Professor Kaldi? Sure. Thank you, Professor Matsuoka. Professor Kaldi, please maybe a short response to that. So the questions of our.
I think the key word is rate. The rate of injectivity versus that we will need to store considerable volumes versus the rate of reactivity is a mismatch. You cannot get that kind of rate that we need to inject with the amount of mineralization that we need. Certainly over time, it might happen, but that CO2 is going to have to be resident in the formation, reacting for considerable long times. The problem with the volcanics, which will react more quickly, is how do you get it in there? It's the injectivity, because you've got relatively low permeability in those sorts of rocks. So, those are the issues we're facing. We talk about it all the time, and it's not an easy solution, unfortunately.
Yes, thank you, Professor Kaldi, on that. Yes, Professor Reza, so maybe this is our task as lecturers to dig and more information to explore about this possibility, right? And also to have this comparison study and analysis for better comprehensions and to better also explain to our students here. Thank you, Professor Kaldi, to that. The committee sadly has given me the cue that the time is almost over for our discussion today. And we do hope that for the next future, we will be able to invite you again, hopefully live in our university, to give us the talk. Yes, since Professor Giancarlo, maybe for you will be the second time, and for Matsuoka Sensei, maybe the first time not the first time in Indonesia, but to come to our campus in Universitas Pertamina. Yes, I think we have met our 3 objectives today. So we have already obtained scientific insight and be able to compare lots of theories and skill acquired in the field of CCUS. And we also obtained information directly from the expert, from Professor John Kaldi and also from Professor Matsuoka. And also, I believe that the professor has already increased the participant motivation to be more active in pursuing in this field and be more contributing to our nations into decarbonization world. So maybe for the last word, maybe Pawawan will have a short.
Yeah, that's a short time. I think I just would like to say thanks to John Kaldi, Professor John Kaldi, and Professor Toshifumi Matsuoka. And then hopefully with your explanation, with your sharing session in this time, so in Pertamina University will, as soon as possible, have a special task force to conduct the CCS and CCUS. And will join with us now, Professor John Kaldi and Professor Toshifumi Matsuoka. And then hopefully in the next year, hopefully everything already normal, and then you will be in Pertamina University directly live. Thank you so much.
Thank you, Professor Wawan. May I ask for all the participants to give a warm applause for our boss professor, Professor John Kaldi, and also for Matsuoka. We have here the icon here in Zoom. Thank you very much for your time, also the opportunity to hear directly from you about the CCUS and also the projection, the scenario, the challenges that we may face, and also the opportunity in this field. Thank you very much for both of you, and I hope Professor John Kaldi and Professor Toshifumi Matsuoka be feeling well and also be in good condition despite in this very sad pandemic. We will hope that will be over soon. Thank you very much again for your experience and also sharing valuable knowledge to all of us. Thank you very much. And I will give again this moderation to our MC. Thank you. Thank you also for the participants for asking actively the questions.
Thank you, Professor. Thank you, Professor John Kaldi, Ph.D., and Professor Toshifumi Matsuoka, Ph.D. That was a very delightful, insightful presentation. Also, thank you for facilitating the panel presentations, Dr. Farah. Moving on to the next agenda, we will be having a performance by Upmore entitled Ikat Aku di Tulang Belikatmu by Sal Priyadi.
Menetaplah lebih lama dari matahari akan kekal semua bahagia dalam rangkuman cerdiknya siasat kita kan larung semua perasaan yang jahat. Ikat aku di tulang belikatmu, biar ku rebah dan teduh sambil dengar ceritamu, ceritaku tentang bagaimana ku temukan rasi bintang di matamu, agar aku tahu kemana aku harus ikat aku di tulang belikatmu, biar ku rebah dan teduh, sambil dengar ceritamu, ceritaku tentang bagaimana aku temukan rasi bintang di matamu, agar aku tahu kemana aku harus
Thank you so much to Marvino Kristandi, Faras Nafa, and Rizky Zeluci from Universitas Pertamina as the Upmore. That was a delightful performance. Now, to all audience, I would like to invite you to a photo group session. Please open your camera and put on your best smiles.
Okay, I will count 1, 2, 3. Please, all participants, kindly open your camera. Everyone. Okay, I will take the first page of the participants first. Okay, I will still wait. Okay. First page, 1, 2, 1, 2, 3. Okay, wait a minute. The second layer, you ready? 1, 2, 3. Last layer, 1, 2, It's great. Okay, thank you so much.
Okay, thank you so much, committee, for guiding us, and thank you
Okay,
everyone
thank
for
you.
turning.
Thank you.
Thank you very much.
Thank you
So much, everyone.
Yeah.
Today's International Upbringing session delivered by Prof. John Kaldi, Ph.D. and Professor Toshifumi Matsuoka, Ph.D., attended by around 100 participants from various institutions. We truly hope that you have had a fruitful experience of learning, sharing, and networking. Ladies and gentlemen, however, we are now has reached an end of today's International Upbringing sessions. Finally, on behalf of the Universitas Pertamina, I would like to express my gratitude to the speakers and my appreciation to all the participants for taking time out of your busy duties to attend the event. We will meet you again on another occasions. We wish you always safe and healthy. Good day and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, John Kaldi.
Yes, good afternoon, everyone. Thank you very much.
so
Professor
much.
Matsuoka,
Stay
and all of
safe.
you.
Profesor Matsuoka,
Thank
thank
you.
you very
Jusna,
much. Profesor John
Kello,
Kaldi.
terima kasih sekali.
Terima kasih Pak Wawan.
Bye.
Semuanya.
Bye. Thank you very much.
Terima kasih.
Izin lift Bapak, Ibu.
Silakan, Farah. Terima kasih.